Hi, and welcome to May, and thanks for coming to check out According to Pete. Today, we're going to talk about OBD2. And not just OBD2, but car hacking sort of kind of in general with a focus on OBD2, right? So if you're looking to get into car hacking, never looked at it before, never really thought about it, but you've always been kind of curious about the stuff that you heard, this is going to be the video for you. And we're going to talk about this connector, right? Ready to hit the board? Let's hit the board. Now, before I get into the history of OBD2, let me try to clean up the definition just a little bit. OBD2 is a communication standard that plugs into a vehicle's native data buses. And it's specifically tailored for emission control and vehicle diagnostic. It has a standardized connector with a semi-standardized pinout and kind of a loose collection of commands that may or may not work. In fact, emission control has everything to do with why OBD2 exists at all. In fact, the whole point is, how is the car running, okay? Now, in my approach to this material, it's not, I'm not just going, we're going to talk about OBD2. I'm looking at this from the position of, I want to get into car hacking, right? I want to know whatever it is I gotta know to get started. And so as I evaluate this material, I evaluate my easiest point of entry against the learning curve I'm gonna have to face, the gear I'm gonna have to buy, and how much satisfaction I'm gonna get at the end of this after learning all of this junk, yada, yada, yada. So keep that in mind. We're gonna revisit those questions as we go. So let's talk about the history of OBD2, sorta. And I say sorta because the accounts I've read have kind of conflicting dates for when one thing happened and another thing happened after, maybe, sorta. Well, anyway, you'll get it. And the history isn't really the important part of the video, but I do want to touch on it so you have an idea of why it exists. Now, think back to the earliest examples of idiot lights, right? Car have problem, light go on, stop car. And the earliest ECUs, these go back to like the late 60s even, the 70s and through the 80s. Companies like Volkswagen, I think Datsun, GM, were all experimenting with ECUs and a data bus between them. So that was kind of it was the backbone that was in existence before, in the late 80s, when the California Air Resources Board requires all cars have some kind of onboard diagnostics for emission testing, right? You remember the 70s and how pollution was the big thing, or one of the many big things. It's still a big thing now, I'm not saying it isn't. This was born out of that era. And being that there was already a bus, a data bus, or several data buses that were accessible, this seemed like a doable thing. Now, around the same time, late 80s, early 90s, the Society of Automotive Engineers, right? And they're a very interesting group that I'd like to do some more reading on, because I don't think they let companies have memberships, right? So this is a whole bunch of like, it's from like the 1900s or 1920s, and technical men, and they're saying men in some of these things, whatever. But they're an interesting group, and they sound like they're making recommendations for the standardization for the connector and the commands. And it seems like a group you want to listen to, because they're not motivated by money, they're motivated by the industry. Seems like a good idea. Well, in the early 90s, after some experience with the original onboard diagnostics, the California Air Resources Board decides that OBD1 sucks. Well, okay, there was no OBD1 before there was an OBD2, but they decide that the existing system isn't what they like, and they take the SAE recommendation, or recommendations, plural, and in 1996 decreed that all cars and trucks in the United States, sold in the United States, must have OBD2, okay? And we're gonna get all into that stuff. Other notable events, in the early 2000s, the EU follows suit, and in 2008, all US vehicles must support ISO 15765-4. And when we get to the connector, which is very soon now, we're gonna talk about exactly what that is. It's the CAN bus, effectively. Remember the last video where we did the CAN bus? This says that's the protocol that must be on the connector. Now, let's talk about the connector. The connector. Couple of efforts, and that's what I got. Looks kind of like the connector. Let's move on. So, this is what it looks like. It is 16 pins, 8 on the top, 8 on the bottom, and this is as you are looking at it, okay? Now, this connector has to be within 2 feet of your steering wheel. Remember that. Now, the pinout for this thing is interesting. First of all, DLC. It's called a DLC, Data Link Connector, okay? Pins 2 and 10. 2 and 10 are defined by SAE J1850, and that is an electrical bus standard. I haven't read the doc. I'm not sure everything that's in it. I'm not going to call it very important for right now, and that'll become clear as we go. But it dates back to 1994. American manufacturers tended to use it. And yeah, we'll get to the end and then I'll explain this. Pins 7 and 15. So 7 and 15, sorry that doesn't, it's a very tiny 15, are defined by ISO 9141-2, which is affectionately called K-line, and ISO 14230-4, which is KWP 2000, or Keyword Protocol 2000. I don't know what that is. Again, I'm not going to call it very important for this conversation, and I'll explain why right now. Pins 6 and 14 are defined as ISO 15765-4. That's the CAN bus. Now, you remember in the previous words that I said that in 2008, it was mandated that every vehicle sold in the United States must have ISO 15765-4. for the purposes of onboard diagnostics, okay? Now, the upshot of that, since everyone's required to have that, these other ones are starting to fade out, sorta, kinda. Couple more points, but first let me say pin 16 is battery voltage, so you can power your offboard, your stuff. And pins 4 and 5 are ground. One is defined as signal, one is defined as chassis, as I recall. They're ground. Now, totally lost my train of thought. You're gonna have to cut some of this. ISO 56.5. Okay. Now, what I want to say about this that you need to know is that these are the things that are firmly defined. All of the other pins on this connector are manufacturer discretion, okay? So various manufacturers put other data buses in there that they don't have to tell you about, they don't have to let you access, blah, 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 blah. The only one that's guaranteed for your use is 15765-4. All the others might be there depending on the manufacturer and depending on whether or not they want to tell you what's there. Oftentimes they won't. A lot of this information is proprietary, and certainly when you get into the command structure of some of these things, it's incredibly proprietary. So you need to know that going in. Okay, now let's stop and think about what we know so far and render some assessments. Now, as I was telling you earlier, as I approach this, I'm looking at it from the point of view of I want to dig in, I want to cause some trouble, and I'm looking for my easiest point of access, all right? Well, now we've looked at the hardware bus. There's a connector, there's the input right there. I've got access to everything. Well, there's a lot of things, right? Every one of those protocols is going to be a pain. Now, since we know that the California Air Resources Board decreed that all cars have to support 15765-4, right, the CAN bus that serves OBD2, we could probably start there. And there are literally dozens of documents that detail every aspect of everything that goes in and out of that connector, right? But because that one is required, we can pare down all those other docs, and we can just whittle it down to 15764-4, 765-4, and SAE J1879. Now, this guy actually details the OBD2 command structure, so that might be a place we go. Right now, if I'm just looking at that connector, I'm looking at this. Am I really gonna do this? Well, okay. I've read something of that document. I didn't pay for it. It was just something I found on the internet. I don't know if I can trust it or not. For all I know, some counterfeiter put this together just to mess with me. But I spent some time looking at raw data coming out of the CAN bus with my Analog Discovery 2. So, notebook, right? I'm an engineer. I was out in my car taking data. I want to read this for you. So, things I figured out. First of all, the setup using the Analog Discovery 2. On the scope function, I can see both the CAN low and the CAN high signals really clear, and it looks really cool. But to interpret the data, and my system is running at 500 kilohertz, so 500 kbit per second, which is, the system I ended up using is really good at figuring that stuff out, but this is just data points going into this to make a decision. Can read values under the logic tab. So if you're using the Analog Discovery 2 and you go under the tab that says logic, this is where you can set it up to actually read the values, the addresses, the bytes, all the stuff that's coming through on the CAN bus. And that's very interesting and complicated and a little bit hard to decipher. Real hard to decipher, as a matter of fact. But I had, my only input was DIO 0 on CAN low. For some reason, it was having a hard time reading the CAN high line, but the scope shows it just fine. But in any case, attached to CAN low, I was able to decode some of that data. The data is interesting. It actually pulses. You get data for about 90.95 milliseconds, and then it quits for 400 milliseconds and the bus is quiet. Now, I don't know the significance of that. As I was saying, I'm just taking data points, right? I want to see what it is that, right, if I'm actually contemplating this, I need to see what I'm dealing with. And this is just the first step, right? So I'm looking at that, I'm like, okay, I can look at the data, I can read the data, I can probably figure out the data, and there's probably some information online that I can go to. But at the same time, I'm still thinking about, am I actually going to do this? I have to weigh this against how much money I got to spend, how much time I have to invest in getting over the learning curve, and looking at these documents. Now, this is what the one that I saw. It's not awful. SAE docs, those are awful. I don't even know what to tell you about that stuff. Again, both of these organizations want money, so the documents you find on the web are going to be maybe sketchy. Hard to say. They didn't come directly from those sources, so I don't know if you can trust them or not. But the SAE docs are horrific. The ISO docs, a little less so. But these are self-described technical people, so they're going to really make it hard to read. So I'm looking at this. And then there's this thing called a scan tool. What's a scan tool? Well, in simplest terms, a scan tool is a device that talks all of the protocols on the OBD2 port, or most of them, and it'll advertise which they do and don't. And it spits out OBD2 on the other side. Now, there are various degrees of scan tool you can get because, and spoiler, it sucks to talk to 15765-4, so they put OBD2 on top of it. In fact, it sucks so much to talk to OBD2 that they put some other stuff on top of that. And if you go look at some of the higher end scan tools that people can get, it's all an interpretation of the data that OBD2 spits out at you. And when we look at the command structure, that's going to become clear. But a scan tool, yeah, it spits out OBD2 on one side and it talks all the protocols on the other. And it can make life a lot easier and for not very much money. So I ended up going with this because I didn't know enough about what I didn't already know. And preliminary looking at the command structure of OBD2 makes it look like, okay, I can get into some trouble there. And you know, we'll talk about that. In fact, let's get into the command structure. So, what does the command structure look like of OBD2? Stock this information away for a few minutes until I get into the examples. I'm gonna take a look at myself. So, there are 10 modes they call them, of OBD2, and they're listed as such. Mode 1, show current data. Mode 2, show freeze frame data. Mode 3, show stored DTCs. What's a DTC? It is a diagnostic trouble code. It's those pesky things that light up those lights in front of you and tell you that your wallet's gonna get lighter. Mode 4, clear DTCs. So this is the command you issue to get rid of them. Mode 5, test results. O2, 6, test results, other. Now these are both oxygen emission related. I haven't quite wrapped my head around the difference. I believe one is for the CAN bus, one is for not the CAN bus. That's not where I'm at yet. Mode 7, show pending DTCs. So your car will not take the first indication of a DTC and flip out. It waits until, at least for the minor ones, maybe the major ones, it'll flip a light on. But for the minor ones, it'll wait for like 3 instances, I think, and then it'll light up a light. So if you've got something that hasn't shown a light yet, it's gonna show up under 7. Mode 8, control operation of onboard components / system. That sounds promising, doesn't it? Well, mode 9, request vehicle info. So there's gonna be like your VIN and stuff in there. And mode 10, permanent DTCs, cleared DTCs. So those are the modes, okay? And each mode has a number of PIDs associated with it. What's a PID? It is a parameter ID, okay? Not all modes have PIDs associated, right? The number can be 0. For example, clear the diagnostic trouble codes. It's just a command, do it. Show stored ones, it's just a command. But these two have a slew of PIDs associated with them. Now, I did this. I got a thing, and I'm gonna show you in a sec, and I tested out a bunch of these things. I'm gonna show you what my results were, and we'll talk to you about how you do it. Okay, now we're getting to the meaty stuff. Now, what I used to do this, right? First of all, my car is 2015 Volkswagen GTI, okay? With about 35-ish thousand miles. I used the SparkFun OBD2 UART board, which I will provide a link to in the video description. Also a OBD2 to, it's not RS232, right? I bought the kit, and the kit that we sell has the board and it has an OBD2 to a DB9 connector. It does not translate to RS232. It just uses the connector as an electrical conduit. But that cable, a USB to UART bridge, like, which one did I use? The FTDI 3.3 breakout, something like that. Any of those will do. And a terminal program. I use TerraTerm, set it up for 9600.8.1 none, and you start issuing commands. It's literally that easy. Now, the device that, the board that I'm using is based on, the part is like STN1110, and it is based on a command set from a part called the ELM327, which at least some number you're going to be familiar with. It might even be pronounced ELM327 because on their docs it looks like capital E, lowercase LM, Elm Electronics. They make the ELM327. But they have a command set, which is fairly well documented and easy-ish to read, sort of, kind of. And besides access to all the OBD2 related stuff, they have their own AT command set that I haven't quite wrapped my head around a lot of it because there's a lot of it. And I was really just fascinated with what I could get directly from the car. But there's a lot of other functionality that comes in the part. which we're not going to talk about today. But issuing commands, right? This board, the SFE, the OBD2 to UART, all it is a terminal to let you enter in the things. Now the commands, right? You enter the mode first. It's a 2-digit hex value. So on the last page where I said 10, it's actually 0A. So if you were doing mode 10, you'd be 0A followed by whatever, if it takes whatever. So hex value here, there's no space between, in this case, 0001 and enter. Now 00 happens to be the request for what PIDs do you support in mode 1, and specifically which ones from 0 to 20 are you going to support. And the car will spit back a value. Now, look at this command. The mode is like what I want to do, and the PID, the parameter ID, is what I want to do it to, okay? That's how you should be looking at this. What I want to do, what I want to do it to. Enter. And the car will spit back something. Now that's a lot of fun. You remember earlier when I said that 15765-4 sucked so bad that they had to put OBD2 on top of it? And OBD2 is so bad that they offer you all kinds of software solutions to figure out what it is it just said. Okay, what it spits back at you is a number of bytes in hex. What those bytes are, they can either be encoded by a formula or a lookup table or what have you, and every one of them is just a little bit different. So every time you make a request of the OBD2 bus, it spits something back at you that you're gonna have to go look up. That blows. So, that's why you have lots of grades of scan tool available. If you don't want to go do that decoding, we got a tool that'll do it for you. Personally, I don't want to do that. And you probably don't want to do that either. If you're watching this video, you do not want something that's really high end probably. You want to dig in. So, that's what you're going to get back. Now, I have a slew of examples that I got off of my car, and that's what we're going to look at now. All right, so here's some examples of what happened in my car, minus my vehicle identification number. I'm not giving you my VIN. So I'm sitting in my car, I got my terminal there, I'm plugged in, and I'm putting in commands 0100 enter, and it spits something back. Okay, now this is most of the raw data, and I'll explain this as we go. Some notes in my notebook. So 0100 is actually PIDs supported. Now the return of this thing is a number of bytes that tells you how many of the PIDs going from 0 up to like 20 or so. It's like how many of the following PIDs that are right in front of me are you going to support? And it will spit back a bit encoded thing that tells you exactly which PIDs in the next ascending 20 or so, and there's a firm number, and I don't know it off the top of my head, but which of those are going to be supported. The car will tell you that, because like I said earlier, they don't gotta. So, the way the data comes back, 0100 enter, and it tells you, the first thing is you get a 1 indicating mode 1, and then you get the next, which is the PID that you requested, and then the information. Now the number of bytes that can be returned is variable. It can be from for some modes 0 and in some cases like 9 more, not sure. I'm still feeling it out. But it's padded at the end of this with these values and you'll kind of see how that happens. So you get mode, you get PID, and then byte A, byte B, byte C, byte D, and these are padded with these values, 13, E8, and E1 if those are not used, and then another one if that's not used. And you'll see that pattern. And in every block that's represented by the which PIDs are supported have different padding values, and you'll see those in the different groupings, okay? It's not super critical. This is just what you're going to see, and I want you to know what you're going to see if you're doing this, okay? Now, as far as the data goes, again, PID supported. This is bit encoded. I don't really care which ones it's supporting right now. If it's not supporting it, I found out it's going to answer with no data. That's interesting. So this is which PID supported. PID 03 is fuel system status. It is another bit encoded. I just wanted to see what it would give back. I don't want it. Okay, it's run. The car's running. The fuel system must be in good condition, right? Okay. 0305, coolant temp. And at the time I took this, it measured the coolant temp at 129.2 degrees Fahrenheit. That is a formula decoding. You can look that up. That seems an unlikely thing because it had been idling for a while. I don't know where that value is coming from. Probably not the engine. 0C, engine RPM. I was at idle. It spits back 760 RPM after decoding per their formula. 0D is speed, tells me I'm sitting still. 1.1 is throttle position, idle, so I was sitting at 12%. Now at this point, I'm seeing like, okay, I see the pattern. I don't have to worry about those values or those values until they change. Now once I got into the next block of PIDs, those padded values changed. And so it's like, okay, so I'm seeing some similarities there. Let's see, I did 1.1. 2.1 is distance traveled with any of your emergency lights on. If you've got an emergency light on, how far have you been driving with that? So remember, when you take your car in to the dealer and you say, oh, it just came on, they can tell if you're lying. Just saying. So how far? In my case, it was 0. Thank you. I'm happy to say that. It isn't always 0, but it was this time. Let's see, 2F, fuel tank level. I was sitting at 39%. These are the values it spits back, and it's 0.1. Yeah. So the bits that I omit are repeated, so take that as granted. 31, distance traveled since DTC's cleared. In my case, it spits back a value of 4394 kilometers. Sorry, I didn't write that down there, but it was a positive value. Let's see, 46 is air temp. This was ambient. It actually spit out 21 degrees Celsius, so low 70s, I think. Fahrenheit. 51, fuel type. This was a disappointment. I was hoping like, sweet, there's gonna be a sensor in there to tell me what my octane limit. No, it doesn't. It's a lookup table, and it says you're using gas. All right, whatever. So that was 46. No, that was 51. Oil temp, 5C, no data. Okay, that was a strange. There's got to be another place I need to get oil temp because that has to be a parameter that's available somewhere. I know it. But for 015C, it was not there. And those are most of the pertinent ones that are going to be in mode 1 and mode 2. All the mode 2 or all the mode 1 PIDs work in mode 2. And all the other modes, not so much. Depends on what you want to do. Bits of interest that I have written down here that I said previously probably. Mode 03, show stored DATCs. Mode 4, clear the DTCs. Mode 7, show pending DTCs. Mode 8, remember that? Mode 8, control other crazy stuff. There's almost no information that I could find on mode 8. Go figure. And lastly, mode 9. A couple of interesting things in there. Report VIN. I did it. It reported correctly. I'm not telling you. And 090A, ECU name. That's odd. Both the VIN and the ECU name are ASCII encoded. So the values that spits back are direct translation to text. And when I asked for the ECU name, it tells me ECM-engine control. Okay, I feel like this is Tron. Engine control. So there you are. Now, this is just to give you an idea of what the raw data is going to look like, the patterns you're going to see, and the decoding that you're going to have to do. We'll talk about that a little more now. So, we've looked at some things. Now you got to make some decisions, right? We talked about OBD2, and We've talked about the lower level 15765-4. You've got to figure out, as I've got to figure out, and I've already made my choice, it's really kind of a no-brainer, but you've got to figure out where you want to inject yourself. Are you going to go the low-level way? Well, let's talk about that. Now, if you do this, you are literally interpreting the CAN data yourself, and you are decoding it, blah, 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 at a very low level. Now, what's that going to get you? Well, it's going to get you a bunch of years older. It will get you to be a guru. I mean, nobody's going to question your knowledge about OBD2, CAN bus, et cetera, and it will give you literally all the control you could ever want, assuming you can figure it all out. So that's a life pursuit. I don't have time for a life pursuit. I'm a working parent. I got things to do, man. So the other way is to go the OBD2 way and use a scan tool. Now, much shorter time investment, right? As we've indicated. Much more information up front to get you going, but there's still lots of unknowns, right? As we talked, the auto manufacturers don't have to tell you everything that's going on the buses that are available through the OBD2 port, okay? There are commands you don't know. There are functions and things that you will never know, probably. They don't have to tell you. But if you can figure them out, that's pretty cool. My point is, I'm not saying there are a lot of unknowns as a negative. I'm saying there are a lot of unknowns that let you go digging, right? Because we're here because we like to dig, we like to figure things out, not because we want to make things easy, but because we want to figure things out. And so what I'm telling you is that there's still a lot of room within the scope of OBD2 to do that. A lot of functionality there. So for me, I'm going this way. I would recommend that you go this way as well. All right, so what gear do you want to get for whichever path you're going to choose here? Now, incidentally, I will provide links in the video description and the blog post for all of these things that I'm recommending, as well as links to further reading, which I highly recommend. There's a lot of information. But if you want to go the hard way, I would highly recommend that you pick up something that will interpret CAN. I really like the Analog Discovery 2 Go Digilant. You guys are awesome. The reason is not only does it interpret CAN, but you get the scope function as well. So in case you're not getting any logic back that you can read, look at it with a scope. Am I seeing something? Yes, no? Very helpful thing. Also, let's see. Oh, it did require a little bit of finessing. I won't lie about that. But you know what? If you're here watching this video, you're probably not looking for the easiest thing. So finesse is like in your wheelhouse. Quit your griping, you can do this. Trust me. Also, you will ultimately need something that will interface with that CAN bus. The CAN 485 board looks to be, by my reckoning, a decent example of that. Now, this is with the knowledge, of course, that you are going to write an interpreter to do what you want, okay? This doesn't have an OBD2 interpreter on it. This is a CAN bus, right? You have a transceiver, you have a controller, so you are in deep. I would also highly recommend you read the work of Charlie Miller and Chris Valsek, okay? Awesome stuff, right? I mean, we've all had to read technical docs, and most of them suck, but these guys, their writing is quite good. A lot of information. It's semi-dense, but it's a really fun read. So I'll provide a link to their site and some of their information as well. Now, if you want to go the easy way, get the stuff that I recommended already. You need an OBD2 to UART bridge. In our case, it is the WIG 09555. Again, I will put links in the video description. Cable, now there is the cable itself has a SKU of CAB 10087, but you can buy these two things together in a kit. It's like 10 bucks more than just this. You will also need an FTDI or a USB to UART bridge like the FTDI 3.0 Breakout, which is Deb 09873. Why that's not actually in the kit in the first place, I don't know. I had to buy it. But you literally plug these things in. You plug the cable into the OBD2 port, that cable into the board, then to the FTDI, to your laptop, open up a terminal at 9600.81n, and you're going. And it's that easy. And you can start poking around right away. That is all I'm going to say today about OBD2 and car hacking in general. Hopefully, that was good information for you as a budding car hacking person to get you going, make some choices, and get an idea of the land that lays before you, okay? I will provide links for additional reading. There is much. Wikipedia is a great place to start. Of course, they've got everything, but there's lots of sources out there. And of course, all the sources are a little bit different in how they present the information. And you'll want to look at a range of them before final calls on anything. I'm just saying. We talked about the hardware. We talked about, yeah, you're ready to go. Thanks for tuning in. Good luck on your endeavors. Read the Chris Valasek and the Charlie Miller stuff because it's amazing. And I'm going to go poke some stuff into my car. Better not run with that. Okay, thanks for coming. See you, bye.